This video is on graphing horizontal motion in one dimension. Question 1. An object can move to the left or right in one dimension. Positive displacement is towards the right and negative displacement is towards the left. Its displacement versus time graph is shown below. So we have 9 lines. The first line has a slope of 0. This means that in this graph, the object is not moving at x equals 4 for the first 4 seconds. And then the object goes to the right. And then the object goes down. And at about t equals 9.5 seconds, the object is at the origin, x equals 0. Then it continues to go backwards to the left. And then it's at rest from 11 seconds to 16 seconds. And then from 16 seconds to 18 seconds, it continues to go to the left. Then it starts moving to the right. And at about 19.5 seconds, it's at the origin. It continues to go to the right. And at 20 seconds, it's at x equals positive 2. Then it's at rest. It's at x equals positive 2 for 4 seconds. Then it goes to the right 3 meters, and it's at x equals 5. Then it's at rest at x equals 5 for the last 5 seconds. Part A, what does the slope of a displacement versus time graph tell us? It tells us the velocity at that specific time. So in the beginning, the slope is 0, so the velocity is 0. Here on the second line, the slope is 2 over 3, so the velocity is 2 meters over 3 seconds. Part B, give all your solutions to 2 significant figures. Determine the displacement and velocity of the object during the following times. So let's take a look at time equals 17 seconds. We're going to go 5 to 17 seconds is here. Where is the object at 17 seconds? It's at minus 6. X equals minus 6. It says here minus 6. What's the velocity at 17 seconds? Well, let's take a look at the slope. Is this slope positive or negative? It's negative. It's going to be 1, 2, 3, 4, negative 4 over 2. So it's going to be negative 2. So we got negative 2. So we could determine the displacement just by reading the graph, and we could determine the velocity by taking the slope. Part C, what is the total distance the object travels from 0 to 30 seconds? So it's going to be 0, then it's going to go plus 2, then it's going to be this distance from plus 6 to minus 4, that's 10. So this is going to be 2 plus 10 plus 0 plus 4 plus 10 plus 0 plus 3 plus 0. So we get a total of 29 meters. What's the displacement of this object from 0 to 30 seconds? Well, that's going to be the final position minus the initial position. So the final position is 5, the initial position is 4. So 5 minus 4 is 1. What does the slope of a velocity versus time graph tell us? It tells us the acceleration of the object at that specific time. Part F. Draw a velocity versus time graph and an acceleration versus time graph. So how do we draw a velocity versus time graph? Well, this is a position versus time graph, so just take the slope. This is 0, the first line, the slope is 0. Then this slope is 2 over 3. Then this slope is minus 10 over 4. What's minus 10 over 4? That's negative 2.5. Then this slope is 0. Then this slope is minus 3 over 2. Then this slope is 10 over 2. This slope is 0. This slope is 3. This slope is 0. So the velocity is just going to be the slope of a displacement versus time graph. And then they're going to want us to draw an acceleration versus time graph. Well, the way we get an acceleration versus time graph is if we take the slope of a velocity versus time graph. And all of these are horizontal lines, so all of these slopes are 0. So the acceleration here is 0 for every time. Question 2. An object can move to the left or right in one dimension. Positive displacement is towards the right and negative displacement is towards the left. Its displacement versus time graph is shown below. Okay? Is the object moving to the left or to the right? Is it speeding up or slowing down? From 2 seconds to 12 seconds, we could see that the object is moving to the left, because it's getting closer to x equals 0. So it's moving to the left. And from 2 seconds to 12 seconds, the speed is about the same because the slope is about the same. Now from 12 seconds to 23 seconds, what's happening? From 12 seconds to 23 seconds, the slope is increasing. You can see that the slope is a constant and then it's increasing to 0. Because it's negative, then it increases to 0. So it's slowing down because the slope increases from the negative to 0 and it's moving to the left. Why is it moving to the left? Because we're below the horizontal axis. From 23 to 29 seconds, what's happening? From 23 to 29 seconds, it looks like the slope is increasing. So because the slope is increasing, we're speeding up. And it's a positive slope, so we're going to the right, speeding up. And finally, from 29 seconds to 33 seconds, it looks like the slope is constant. And it's positive, so we're going to the right. So determine the displacement and the velocity of the object at these 3 times. 12 seconds, 23 seconds, 29 seconds. The displacement, we could just read from the graph. The velocity, we need to take the slope. And how do we take the slope? We take 2 points. Part C, what is the total distance the object travels from 2 seconds to 33 seconds? It's 34 meters. Because we're going to go from 10 to minus 7, and then from minus 7 to 10. So that's 17 plus 17. Part D, what is the displacement of the object from 2 seconds to 33 seconds? Well, the displacement is the final position minus the initial. So it's going to be 10 meters minus 10 meters, which is 0. Question 3. An object can move to the left or right in one dimension. Positive displacement is towards the right, and negative displacement is towards the left. Its displacement versus time graph is shown below. So it looks like we start at minus 12 and we end at minus 12. Is the object moving to the left or right? Is it speeding up or slowing down? So from 2 seconds to 4 seconds, it looks like the slope is positive and we're decreasing our speed because the slope is decreasing. So we're moving to the right and slowing down because the slope is decreasing. Now what about from 4 seconds to 14 seconds? It looks like we're moving to the right, but we're slowing down because the slope is decreasing. So moving to the right, slowing down. Now from 14 seconds to 29 seconds, what's happening? It looks like we're moving to the right, but the velocity is decreasing because the slope is decreasing. I apologize. We're moving to the left because this is a displacement versus time graph, and if we take the slope, we're speeding up towards the left. And then from 29 to 38 seconds, it looks like this slope is pretty much constant, almost, but we're moving to the left. So determine the displacement and the velocity at these 3 times. The displacement we could just read from the graph. And the velocity we have to take the slope. So we need 2 points. What's the total distance the object travels? Well, it's going to be, it goes from minus 12 to positive 8. Sorry, minus 12 to positive 9. And then from positive 9 to minus 12. So that's 21 plus 21. And the displacement is 0 because we end at minus 12 and then we start at minus 12. So here's minus 12 and here's minus 12. So those problems were displacement versus time graphs. Now we're given a velocity versus time graph. An object had moved to the left or right in one dimension. Positive displacement is towards the right and negative displacement is towards the left. Its velocity versus time graph is shown below. So what does the slope of a velocity versus time graph tell us? It tells us the acceleration of the object. So let's determine the velocity and the acceleration during these times. So the velocity during 3 seconds, we could just read it from the graph. So about 3 seconds, the velocity is 5 meters per second. 6 meters per second. What's the acceleration at 3 seconds? Well, it's the slope of this line. What's the slope of this line? 0. So once again, the velocity we can read from the graph. The acceleration, we need the slope, and for the slope we need 2 points. Part C, what does the area under a velocity versus time graph tell us? The change in displacement. So find the displacement of the object from these times. We just take the area under the graph between those 2 points. Determine the total distance the object travels. Well, for part E, we just need to add up part D. Determine the total distance the object travels from 0 to 29 seconds. So we're just going to add up all of the areas under the graph. So it doesn't matter if it's positive above the horizontal or negative below the horizontal. It's always going to be adding up the area under the graph. So here we have 5 times 6. Then we're going to have 1/2 base times height. 1/2 2 times 6. then 1/2 7 times 5. We just take the area under the graph. And that's what we do here. Now, part F, determine the displacement. You see we're always adding here. Here we could be subtracting for displacement if we're under the horizontal axis. So here, when we're above, this is positive displacement. When we're below, this is negative displacement. Above, positive displacement, below, negative displacement. So if you look at part E and F, the magnitudes are always the same, but the sign could be negative for displacement. Part G, draw an acceleration versus time graph and a displacement versus time graph. Well, how do we draw an acceleration versus time graph? We take the slope of a velocity versus time graph. So we just take the slope of each line. And now let's try to find the displacement versus time graph. We have to find the area under the graph first, because we're integrating. So this is what the displacement versus time graph would look like roughly. So from t equals 0 to t equals 5, the area under the graph is 30 meters. So this area, we should go from displacement equals 0 to displacement equals 30 at 5 seconds. And then from 5 to 7, the area under the graph is plus 6. So we should go from 30 meters to 36 meters. And then from 7 seconds to 9 seconds, the area under the graph is minus 5. So that means we should decrease our displacement by 5 meters. So you get the point. We have to take the area under the graph of the velocity versus time graph to find the displacement. So this is also a velocity versus time graph. An object can move to the left or right in one dimension. Positive displacement is towards the right and negative displacement is towards the left. Its velocity versus time graph is shown below. So you could see from 2 seconds to 12 seconds, the slope is almost the same. And then from 12 seconds to like 23 seconds, the slope increases to 0. And then from 23 seconds to 33 seconds, the slope increases from 0 to something positive. So is the object moving to the left or right? Is its acceleration increasing, decreasing, or constant? So from 2 seconds to 12 seconds, the slope is negative, so the acceleration is negative, and its velocity is positive. So it's like going to the right but slowing down. So it's moving to the right because the velocity is positive and it's slowing down. From 12 seconds to 23 seconds, from 12 seconds to 23 seconds, it's moving in the negative direction, and then its maximum velocity in the negative direction is going to be 7 meters per second to the left. So it's moving to the left and speeding up and then slowing down. So you could see it's speeding up, but then it slows down because the slope goes to 0. Then from 23 to 29 seconds, you could see that it's moving to the left, but it's slowing down. Why is it moving to the left? Because we're still below the horizontal axis. It's moving to the left and it's slowing down and it stops. And then from 29 to 33 seconds, it's speeding up and moving to the right. It's speeding up because the slope is positive, and it's to the right because we're above the horizontal axis. Determine the velocity and acceleration of the object. Remember, the velocity we could just read from the graph. The acceleration, we have to take the slope. What do we need for the slope? 2 points. Determine the total distance the object travels from 2 seconds to 33 seconds. We need the area under the curves. So we'll just get an approximate answer. The displacement, remember, when we're above the horizontal axis, the displacement is positive. When we're below the horizontal axis, the displacement is negative. So that's why there's a negative sign here, and there's always a positive sign for distance. Question 6. Once again, this is a velocity versus time graph. An object can move to the left or right in one dimension. Positive displacement is towards the right and negative displacement is towards the left. Its velocity versus time graph is shown below. So check it out. So part A, you could read this and pause the video and try to understand what's happening. So from 2 seconds to 4 seconds, it's moving towards the left because the velocity is negative. And it stops at 4 seconds. So it slows down. It goes from minus 12 meters per second to 0. And then from 4 seconds to 14 seconds, we're speeding up. But you could see the slope is decreasing. So we're speeding up, but the acceleration is decreasing. Then from 14 to 29 seconds, you could see that we're slowing down and acceleration is negative. So we're going to the right because velocity is positive. We're slowing down, but moving to the right. And then finally, from 29 seconds and on, it looks like the slope is decreasing or almost the same, and we're moving to the left because the velocity is negative. From 29 seconds and on, the velocity is negative. Part B, determine the velocity and acceleration of the object during the following times. Remember, the velocity you could just read from the graph, and the acceleration you could just take the slope. So at 4 seconds, the velocity is 0. At 29 seconds, the velocity is 0. And at 14 seconds, the velocity is about 9. There's a mistake. At 14 seconds, the velocity should be 9. So this should be the number 9. And the acceleration, remember, we need to take 2 points. And we draw a line and we take the slope. So once again, this should be the number 9. Part E, determine the total distance the object travels from 2 seconds to 38 seconds. We need to take the area under the curves. So we could count each box, or we can get an approximate answer by using the area under a triangle equation, and that's exactly what I did. So you take the area under the curve using approximately a triangle equation, and this is what you get. And the displacement, remember, if we're under the horizontal axis, then we get a negative sign. If we're above the horizontal axis, then we get a positive sign. That's the difference between displacement and distance. Congratulations, take a break and play this video game. Get your physics classmates and your teacher to play it also.